we're going to start talking about something today called the greatest common factor. This is something that we're going to use with the rectangle area models that we've been doing. The one that we did in the opener here. We're going to use this with that to do something called factoring later on. Okay. Right now we're going to keep it pretty simple. We're just going to talk about how we find the greatest common factor of some numbers. So I want to break it down. We'll start pretty simple here. My first question is, what is a factor? I've got most of it here, so we just need to fill in the blank. So factors are numbers that you do what to get another number? Malik? Multiply, exactly. So factors are numbers that we multiply together to get another number. It's a pretty simple idea, right? So for example, 12 is 3 times 4, right? So what are the factors? What are some factors of 12? I just said some. 4 and 3, right? Because we can multiply 3 times 4 to get 12. So some factors of 12 would be 3 times 4. Are those the only factors of 12? Okay, 2 is a factor of 12 because you can multiply 2 times 6. In fact, 6 is a factor of 12. There's some more. There's a number that's a factor of every number. What number is a factor of every number? 1. You can always multiply 1 times something to get the number, right? So 12 actually has a lot of factors. It has 1 as a factor, 2, 3, 4, 6, and I'm missing one. 12. Yep, because 1 times 12 is 12. All right, so a factor is just a number that you multiply to get another number. A factor pair is what? What do you think? No, doesn't have to be even. What do you think, Aiden? 2 numbers, exactly. So a pair, if you think about what a pair is, a pair of shoes is how many shoes? Or a pair of gloves? 2, right? So a factor pair is 2 numbers that multiply to get a number. All right, so it's 2 numbers that go together. So when we're talking about factors, the number 12 has a bunch of factors. 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 12 is a factor. When we talk about factor pairs, we need 2 numbers that go together. All right, so for 12, what number would go with 3? What would be the factor pair with 3 to make 12? 4. So 3 and 4 are a factor pair of 12. Does that make sense? Or what's the factor pair that goes with 1 to make 12? 12, right? So 1 and 12 go together. All right, so a factor pair is 2 numbers that you multiply together to get another number. Okay, a little bit different than a factor. So first example, what we want to do is we want to list the factor pairs of 24. So what we're going to do is list numbers, two numbers at a time, right? The easiest way to do this is start with the one that we know is always going to work. What's always going to work? 1. All right, so the first factor pair is 1 and 24. Now you can write it like this, 1 comma 24. Since we're writing a pair of numbers, you can put a comma between them. Or if you want, you could write it as 1 times 24. Okay, they mean the same thing, right? Since we're looking for factor pairs, we know we're multiplying them together, so you don't have to show its multiplication, but you can do that. I'm going to list it with the comma, but if you put multiplication symbol, that's fine too. Okay, so starting at 1, let's just work our way up. Is 2 a factor of 24? Does 2 go into 24? How many times? What do we multiply by 2 to get 24? Okay, good. What if you didn't know that? How could you figure it out? No. We don't multiply because 2 times 24 doesn't give us 12, right? We divide. So if we know one number, but we don't know the other number, we can do 24 divided by 2 to get the other factor pair, right? Okay, how about 3? Does 3 work?
No.
Let's try it. 24 divided by 3. 24 divided by 3 is 8. That means that 8 times 3 is 24. All right, how about 4? Does 4 work?
Yeah.
Yep. Okay, that would be 6. Because 4 times 6 is 24. How about 5? Does 5 work? Why not? Yeah, well, it's not because it's odd. Because we could have odd numbers in there. We have 1 and 3 are already there. But, yeah, 24 is not divisible by 5. So 5 doesn't work. So the next one would be 6. Does 6 work? How do we know 6 works? It's already on the list, right? So if we get, yeah, so we actually already have 6 on there. We don't need to list it again. So I don't need the 6 either. Okay, do I need to check 7? Okay, I'm actually done. I know that there are no more. Does anybody know why there can't be any more factor pairs? Yeah, we already got 6. That's the last number we checked. So any higher number should already be on the list here. So once we get to a number that we already have, you're done. So there's all your factor pairs of 24. So let's go to example 2 and do factor pairs of 36. I want you to try this one on your own. All right, so we're always going to start with 1. What goes with 1 here? 36, okay. Does 2 work? Does 2 go into 36? Yeah, we can check that. We can do 36 divided by 2 and we get 18. So that means that 2 and 18 are a factor pair here, right? Okay, how about 3?
12.
Yeah, 36 divided by 3 gives us 12. So 3 and 12 would be a factor pair for 36. How about 4? 9, okay. So we do 36 divided by 4 and we get 9. How about 5? No? 36 divided by 5, that gives us a decimal, doesn't it? Gives us 7.2, that's not going to work. How about 6? 6 times 6, right? Now, since I have 6 already on the list, do I need to put both of them on here? Yes. We're looking for factor pairs, which means we need 2 numbers and multiply to get 36. So even though we already have 6 on the list, we need the 6 to go with it because they have to multiply to get 36. I know I can stop, though. How do I know that I can stop? Well, yeah. Now our next number is going to be 7, which is higher than this number right here, so we can stop. So once we get to a number that we've already got on the list, we're done. We have 6 already, we're done. Easy enough, right? Okay, if I asked you to just list the factors of 36, what would you do? What are the factors of 36? So the difference is I'm not asking for factor pairs. I'm just asking for factors. What would they be, Levante? 1, 2, 3, 4, 6, 36. You're missing 3 of them. They're up there. 18, 12, and 9, right? Okay, I probably would have listed them in order. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. So one way to find all the factors of a number is list all the factor pairs and just take the numbers from the factor pair list. That gives you all the factors. All right, moving on. Factors of a number are always what or equal to the number. So if I'm looking for factors for 36, what did you notice about all those factors? 1, 2, 3, 4, 6, 9, 12, 18, 36. They're all greater than 36?
No.
They're all less than 36, right? So the factors of a number are all less than or equal to. Remember, 36 is a factor of 36. But is 36 less than 36? It's equal to, right? So it could be less than or it could be equal to. So when we ask for a factor of, say, 8, if you give an answer like 16, does that make sense? No, because it's not less than. All right, so when we're talking about factors, we're talking about numbers that are going to be less than that number. All right, next question. What do you think we're going to call it when a number is a factor of every number in a group? So if we have more than one number and we know it's a factor of both numbers. That's exactly right. It would be a common factor. So a common factor is a number that's a factor of every number in a particular group. So our next example, example 3, we want the common factors of 24 and 36. How can I figure out what 24 and 36, what factors they have in common? Let me do something here real quick. I'm going to write down the factor pairs that we had for 24 and 36 real quick. So here's our factor pair list for 24. You have that for example 1. Here's our factor pair list for 36. You have that for example 2. So how do I figure out which ones they have in common? Aiden? Yeah, just look for the ones that are the same. Exactly. So we have 1, right? You don't have to circle them, but I'm going to circle them so we can see. But they both have 1 in common, so we'll list that one.
They both have 2.
In fact, guess what? Every number has 1 in common, right? Since 1 is always a factor of every number, 1's always going to be a common factor also. All right, what else do they have in common?
2.
They both have a 2, so we'll list that one. Do they both have a 3?
Yes.
Okay, we'll list that one then.
They both have 4.
They both have a 4, okay. So we'll list that one. kind of a lot of them, isn't it? They both have a 6. Okay, they both have a 6. So we'll list that one. This one's got another 6. Okay, yeah, they don't both have a 9, but they do both have a 12. Good. So we've got 12 in common. And is that it? Yeah. So these numbers right here, this whole list right here, these are what we call common factors because they're factors of both 24 and 36. You guys know what it means to have something in common, right? Okay. So that's exactly what we're saying here. They have these factors in common. All right, so one more thing to add on. We're talking about greatest common factors today, right? So I'm missing one of the words there, the greatest common factor. We know what a common factor is. What's a greatest common factor? So out of all those numbers we just listed, what's the greatest common factor? 12. Why? It's the largest out of all of the common factors. So we look at that list of common factors, and the biggest number on that list is the greatest common factor. So anybody remember how we abbreviate greatest common factor? GCF. Yeah, it's pretty easy, right? GCF. So if I use the word GCF, you should know what I'm talking about. You know I'm talking about the greatest common factor. So the greatest common factor is the one number that's on both lists, that's a factor of both numbers, that is the greatest, the biggest. All right, so then the last question is, what is the GCF of 24 and 36? 12. Why is it 12? Because 12 is the biggest number that we wrote in that last list in example 3. So here's what we did. We talked about what factors are. We talked about what factor pairs are with the factors. Then we talked about what a common factor is, meaning if we have two numbers, what factors they have in common. And then the GCF is the biggest of all those. Now, if I want to find the GCF of two numbers, I can go through all of those steps if I want. I can list all the factors, I can see which ones they have in common, and then I can see which one's the biggest. The problem is that's kind of a lot of work, and there's a good chance that you might forget something if you're not real careful. All right, so that is one way to do it. If you just think about all the factors of 24 and 36 and just try to find the biggest one, you're going to get 12. What we're going to do is we're going to go through a little bit different way to do this. We're going to go back and use something that we used a lot during second triad when we were talking about square roots, even though it doesn't have anything to do with square roots now. And this way, the steps that we're going to take, you're going to make a lot fewer mistakes. Okay? Just like always, you're going to be allowed to use your notes on any tests or quizzes that we take or homework that you're doing. So be sure that you keep these notes handy if you forget what to do. So real quick, let's go through what we did here. One way to find the GCF. This is what we just did. So if we want to find the GCF of two numbers, we want to list all of what first? The factor pairs. All right, so we're going to start by listing the factor pairs. So we're going to list all the factor pairs of each number and then pick which one. Fill in this blank here for me. What's that? The greatest, yeah, or the biggest, or however you want to say it. But we're going to pick the greatest number that is a factor of both numbers. Okay, so if I want to find the GCF of 24 and 36, I can list all the factor pairs of 24, list all the factor pairs of 36, and then just look in those and see which number happens in both lists and that's the biggest. Okay, what number, or is it possible to not have a GCF at all? Is that possible? Why not? What number always has to be a GCF? Or could be a GCF? Okay, but what number could always be a common factor? 1. Right? So even if they don't have anything else in common, 1 can still be the GCF. So if you have something like 7 and 12, the only number that goes into 7 that also goes into 12 is 1, so 1 is the GCF. All right, so you always are going to have a GCF, but it's possible that the GCF is 1. Okay, now, like I was saying earlier, this way, when we do these 3 steps, we're going to do the same thing. We're going to find the GCF of the next example we're going to do is 12 or 24 and 36, but we're going to go through these 3 steps and we'll make fewer mistakes this way. Okay, so the first thing we're going to do is we're going to write the prime factorization. You guys remember that word, prime factorization? Okay, So we're going to write the prime factorization of each number. How do we write the prime factorization? What are we going to use? We're going to use a factored tree. Okay, so we're going to make a factored tree for the numbers that we want to find the GCF of. Step 2, we're going to look for, what do you think? What do you think we're looking for that's going to be in both lists? Not pairs. What did you say? Just factors, yep. So we're going to write the prime factorization. Remember, when we write the prime factorization, what order do we write the numbers? In order from least to greatest. So this is just a reminder here. When we write the prime factorization, we're going to write from least to greatest. Okay, so we write the prime factorization. Then we're going to circle every factor that appears in both lists. And we're going to go through these steps together with the next example so you can see exactly what this means. And then step 3, we're going to write out the list of factors that appear in both lists. So the things that we circled in step 2. And what do you think we're going to do with those factors? We're going to multiply them together. Yep. Remember, factors are numbers that we multiply together to get another number. So we're going to take that list of factors that are in both lists and multiply those together. That's going to be our GCF. All right, so let's do that with the same numbers that we've been working with, 24 and 36. The first step says to write the prime factorization, right? So we're going to start by making a factor tree. How does 24 factor? 12 times 2 would be a way to do it. We'll circle the 2 since that's prime. Remember, we want to get the prime numbers here. And then how about the 12? 3 times 4, okay. Circle the 3. How about the 4? 2 times 2, okay. Let's move over to 36 then. How does 36 factor? 6 times 6, and then each of those 6's is going to be... Okay. Now, did I write the prime factorization here? No, this is just a factor tree, right? The first step says to write the prime factorization. So I'm not done with the first step yet. That was just helping me with the first step. The first step, I want to write the prime factorization. So I'm going to write 24 equals what? What does 24 equal? Write them in order. Least to greatest, right? 2 times 2 times 2 times 3. No, we don't want to, and you'll see why, but we don't want to use exponents here because then, well, that'll kind of get in our way. We'll see why in just a second. All right, so this is the prime factorization of 24. How about 36? 2 times 2 times 3 times 3. Okay, so that's the first step. We did the prime factorization using a factor tree, and then we wrote it out, prime factors from least to greatest. Now, what does the next step say? Step 2. Sharon, can you read it for me? Step 2. Mm-hmm. So we want to circle every factor that appears in both lists. Now, to help us with something later that causes confusion, I'm going to make one circle for each number, or each pair that they have in common. So what do they have in common, Scott? 2. Okay, so they have a pair of 2's in common. All right, so they have that in common. What else? Okay, they have another 2 in common. What else? They have 3's in common. Okay, what else? That's it, right? Okay, so that's step 2. Now, our last step is what? Trevon, now that you know where we are, you can help me out here. Step 3 says what?
Write out the list of factors that appears in both lists.
Okay, so we want the factors that are in both lists. We have 2's in both lists, we have another pair of 2's in both lists, and then we have a pair of 3's in both lists. So what they have in common, how many 2's do they have in common? Do they have 2 2's in common or 4 2's in common?
2.
Only 2, right? So each one of them only has 2 2's in common. So we're going to have 2 times 2 times, what else do they have in common?
3.
A 3. Nope. There's only 1 3 in common, right? We only circled 1 3 in each list. Be very careful about that. Just because we circled a 3 in this list and a 3 in this list doesn't mean that there's 2 3's in both of them. There's still only 1 3 in each list that they have in common. All right, so then the last thing we need to do, we're not quite done. Nope. Yeah, multiply it out. 2 times 2 is 4, times 3 is 12. Now, I want you to look up at example 4. Example 4 asks you to find the GCF of 24 and 36. Did you get the same thing? Yeah. All right, so this right here, what we did, is the same thing that we did in examples 1, 2, 3, and 4 together. So all of this work right here, it kind of seems like a lot, but it replaces everything we did in 4 examples earlier. Does that make sense? Okay.